Hello, my dear students. How are you all? I'm fine. I'm Khandekar Fazler Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. My dear students, during this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some important topics from chemistry first paper, chapter 2, qualitative chemistry. And our first topic is Bohr's atomic model. My dear students, in 1913, Niels Bohr proposed a new model of the atom which explained some of the drawbacks of Rutherford's model. The model is known as Bohr's atomic model. Bohr's theory was based on Planck's quantum theory and was built on following postulates. Postulate 1, postulate of energy level, postulate 2, postulate of angular momentum, and the last one is postulate of energy emission. Now, we discuss about the first postulate. Electrons move around the nucleus in specific permitted circular path and in no other without radiating any energy. These orbits are referred to as energy levels. The orbits are given the letter designation small n. The energy levels are numbered 1, 2, 3, etc. These are also denoted by English letters started with K, L, M, N. So, when n equal to 1, that is K shell, when n equal to 2, that is L shell, when n equal to 3, that is M shell, and when n equal to 4, that is N shell. Now, postulate of angular momentum. In a particular energy level, the angular momentum of electron is fixed and it must be an integral multiple of h by 2 pi. The angular momentum mvr equal to nh by 2 pi. Here n equal to Planck's constant, m equal to mass of an electron, r equal to distance of an electron from the nucleus, v equal to velocity of electron, and n equal to 1, 2, 3, etc. Now, postulate number 3, postulate of energy emission. While moving in any of the fixed circular orbits, electrons neither emit nor absorb any energy. Therefore, in each of these orbits, the energy of an electron remains the same of stationary. Energy is absorbed or emitted when an electron moves from one energy to another energy level. If an electron jumps from higher energy level, that is E2, to lower energy level, that is E1, the emitted energy is equivalent to E2 minus E1. However, if an electron jumps from lower energy, that means E1, to higher energy E2, the energy absorbed will be the equivalent to E2 minus E1. So, the absorbed or emitted energy can be expressed as del E equal to E2 minus E1 and del E equal to h nu, where h equal to Planck's constant, nu equal to frequency or emitted or absorbed radiation. Now, we discuss about the success of Bohr's theory and its necessity. First one, Bohr's atomic model can explain the stability of atoms. According to Bohr's theory, while moving in a fixed stationary orbit, electron does neither absorb nor emit any radiation. Moreover, when revolving continuously around the nucleus, electron does not fall on the nucleus. Bohr's theory can explain this also. Spectra of one electron system, such as hydrogen atom or ions like helium plus, lithium 2 plus, beryllium 3 plus, can be explained by this theory. Applying the Bohr's theory, it is possible to calculate the radius of stable orbits. The calculated value of radius of hydrogen atom's first orbit is found to be equal to experimental value. This theory gives the idea of principal quantum number, which gives the idea of other quantum numbers at a later time. It has been possible to calculate the amount of electron energy of revolving electrons at definite energy levels. The theory makes it easier to calculate the amount of energy absorbed or emitted when electrons jumps from one energy level to another. Rydberg constants calculated from Bohr's theory has been found to be equal to the experimental value, that is 109678 centimeter inverse 1. With the help of Bohr's theory, radius and energy of hydrogen atoms orbit can be determined successfully. My dear students, now we discuss about the limitation of Bohr's atomic model. First one, spectra of atoms or ions having two or more electrons, that is multi-electron system, cannot be explained with the help of Bohr's theory. Limitation number 2, Bohr's theory cannot give any explanation for the splitting of spectral lines under the influence of magnetic field, that is Zeeman effect, or under the effect of or influence of electric field, that is Stark effect. That means for the formation of fine line structure of atomic spectra. Bohr's number 3, Bohr's atomic model is two-dimensional and hence fails to give any idea about the actual three-dimension electronic model of atom. Number 4, according to de Broglie 1923, a teeny particle like electron has dual character, that is, electron has particle as well as wave nature. Bohr treated electron only as a particle, that is, Bohr's model ignored the dual character of electron. Limitation number 5, according to Bohr's atomic model, an electron moves around the nucleus along a fixed circular path with a definite velocity. But according to Heisenberg's uncertainty principle, it is impossible to measure simultaneously both the position and velocity of a subatomic particle like electron with absolute accuracy at a particular instant. Thus, Bohr's theory directly contradicts Heisenberg's uncertainty principle. And number 4, Bohr's atomic model could not explain the ability of atoms to form molecules with different geometrical shapes. My dear students, now we discuss about the comparison between Rutherford's atomic model and Bohr's atomic model. First one, Rutherford's atomic model is based on classical mechanics, and Bohr's atomic model is based on Planck's quantum theory. Second, according to Rutherford's atomic model, electrons can move in any circular orbit of any radius around the nucleus. But according to Bohr's model, electrons can only move in certain stationary orbits instead of moving in any circular orbit of any radius. Number 3, according to electromagnetic theory, revolving electrons around the nucleus will continuously lose energy. Hence, the electrons must, must gradually spiral in towards the nucleus. The radius of electron orbit will gradually decreases and it will fall into the nucleus. So, the stability of atom cannot be explained by Rutherford's model. But according to Bohr's model, during moving in an orbit of definite energy, the electrons do not emit any energy. So, the electrons do not fall to nucleus losing energy. Therefore, this model can explain the stability of atom. My dear students, number 4, according to Rutherford's model, continuous atomic spectra should be obtained because of electrons' continuous emission of energy. But in reality, spectral lines are obtained from atoms. Rutherford's model cannot explain the origin of atomic line spectra. But according to Bohr's model, radiant energy is emitted when electrons jump from higher energy to lower energy. The energy difference between two energy states is fixed. As a result, the frequency of emitted energy is also constant, results in producing line spectra. Bohr's theory can explain the origin of atomic spectra. And the last one, number 5, radius of orbit, momentum of electron, energy and frequency of line spectra cannot be determined by Rutherford's atomic model. Radius of orbit, electrons, momentum, energy and frequency of line spectra can be determined with the help of Bohr's atomic model. My dear students, let's discuss about some mathematical problem from this chapter. Our first question, the radius of the fourth energy level of an atom is 8.5 into 10 to the power minus 8 centimeter. Calculate the velocity of the electron in this energy level. Here given mass of electron is 9.11 into 10 to the power minus 28 gram. So, here given mass of electron equal to 9.11 into 10 to the power minus 28 gram, that is 9.11 into 10 to the power minus 31 kg. N equal to, here fourth shell, fourth energy level, so N equal to 4. My dear students, according to Bohr's atomic model, we get mvr equal to nh by 2 pi. So, v equal to nh divided by 2 into 2 pi into m r. The given radius here, the given radius r equal to 8.5 into 10 to the power minus 8 centimeter. So we have to convert it as meter unit, and this is 8.5 into 10 to the power minus 10 meter. So we get m r n pi, and what is the value of h? H is Planck's constant, and the value of Planck's constant is 6.626 into 10 to the power minus 34 joule second. So we calculate the value of velocity, that is n equal to 4 into Planck's constant 6.626 into 10 to the power minus 34, 2 into pi into the value of pi equal to 3.14. So we can all write here 3.14. Mass of electron is 9.11 into 10 to the power minus 31, and radius of the atom is 8.5 into 10 to the power minus 10. So we get the value 5.45 into 10 to the power 5, 5.45 into 10 to the power 5 meter per second. So the velocity of the electron is 5.45 into 10 to the power 5 meter per second. This is the answer. My dear students, here given our second mathematical problem. Here given one electron of an atom has energy 9.8 into 10 to the power minus 19 joule and 6.3 into 10 to the power minus 19 joule in two energy states. If the electrons transfers from higher energy state into lower one, then calculate frequency and wavelength of the radiated ray. So my dear students, now according to Planck's theory, we can write del E equal to h nu. Now we know that del E equal to E2 minus E1 equal to h nu, or nu equal to E2 minus E1 divided by h. My dear students, now here given E1, this is E1 equal to 6.3 into 10 to the power minus 19 joule, E2 equal to 9.8 into 10 to the power minus 19 joule, and we know that Planck's constant equal to 6.626 into 10 to the power minus 34 joule second. Now nu equal to E2 minus E1, that means 9.8 into 10 to the power minus 19 minus 6.3 into 10 to the power minus 19 divided by 6.626 into 10 to the power minus 34. So now we get the value is 5.282 into 10 to the power 14 per second, that is hertz. So the frequency of this shifted electron is 5.282 into 10 to the power 14. Now, my dear students, we have to calculate the wavelength of the radiated ray. We know that means we get nu equal to c by lambda, or lambda equal to c by nu. We know that c equal to 3 into 10 to the power 8 meter per second, and we put the value 3 into 10 to the power 8 divided by the value of nu equal to 5.282 into 10 to the power 14, and we get the value is 5.68 into 10 to the power minus 7, 5.68 into 10 to the power minus 7 meter. My dear students, if we convert this unit meter to nanometer, then we have to multiply 10 to the power 9. 5.68 into 10 to the power minus 7 into 10 to the power 9 nanometer. So, the wavelength is 568 nanometer. My dear students, here you have to know that 1 meter equal to 10 to the power 9 nanometer. So, the value of wavelength nu equal to 5.282 into 10 to the power 14 hertz, and wavelength is 568 nanometer. My dear students, our next question is calculate the radius and velocity of a moving electron of hydrogen atom in the third energy level. We get my dear students, radius r equal to n square h square divided by 4 pi square m z square. So, here n equal to 3, h equal to h is Planck's constant 6.626 into 10 to the power minus 27 r second. Mass of electron m equal to 9.11 into 10 to the power minus 28 gram. For hydrogen atom, my dear students, for hydrogen atom Z equal to 1, and the value of E, charge of E equal to 4.8 into 10 to the power minus 10 ESU, and pi equal to 3.1417, that means 3.14. So 3 square into 6.626 into 10 to the power minus 27 square divided by 4 into 3.14 whole square into 9.11 into 10 to the power minus 28 into 1 into 4.8 into 10 to the power minus 10 So we get the value is 4.764 into 10 to the power minus 8 centimeter. So the radius of this hydrogen atom in the third energy level is 4.764 into 10 to the power minus 8 centimeter. My dear students, again we know that mvr equal to nh by 2 pi according to Bohr's atomic model. So V equal to nh divided by mr 2 pi. Okay, my dear students. Now n equal to 3, h equal to 6.626 into 10 to the power minus 27, m equal to 9.11 into 10 to the power minus 28, r equal to 4.764 into 10 to the power minus 8 into 2 into pi. So the value is 7.29 into 10 to the power 7, 7.29 into 10 to the power 7 centimeter per second. If we convert this value to meter per second, then we get 7.29 into 10 to the power 5 meter per second. So my dear students, we can say that the velocity of moving electron is 7.29 into 10 to the power 5 meter per second.